Why do some scientists believe that humans may never truly understand the fourth dimension? When we talk about four-dimensional space, many people feel unfamiliar with the concept. Some even find it completely incomprehensible. Take a look at this image. Your first reaction might be to think it's a hexagon made up of 6 triangles. But once the image begins to rotate, we're surprised to discover it's actually a cube. A flat image suddenly appears to have depth. It transforms from 2D to 3D. This is just a visual illusion, but it reveals something important. Our brains are very good at filling in 3-dimensional structures from 2-dimensional information. But if the image never moved, we'd likely never realize it contained a 3D structure at all. This is similar to how a life form in a 2-dimensional world might struggle to understand a 3D object. In geometry, dimensions have a clear definition. They represent the number of coordinate axes in a space. A one-dimensional space is just a straight line. It only has one direction. If a form of intelligent life existed in 1D, it could only move forward or backward along that line. It wouldn't even have a concept of left or right. Now, if we add a direction perpendicular to that line, we create a 2D space, a plane with length and width. Life in this plane can move up, down, left, or right, but still wouldn't be able to perceive a third direction. Now imagine a little ant scientist living in this 2D world, trying to measure the size of the universe. It crawls along a straight line until it reaches an edge, and then somehow ends up on the other side. To the ant, the universe must be finite with a clear boundary. But if we twist that 2D plane into a Möbius strip, the ant will never find an end. It would come to a very different conclusion. The universe is infinite. However, from our 3D perspective, we know it's just a closed, twisted 2D surface. A Möbius strip is a topological surface with no clear inside or outside. This example shows that when we move up in dimensions, our existing logic breaks down. Our sense of boundaries must be redefined. Now, add one more direction perpendicular to both length and width, and we enter 3D space. Here, we can move freely up, down, left, right, forward, and backward. We can move in 360 degrees of freedom. But even with all that, we're still like that 2D ant. We're still puzzled by a familiar question. How big is the universe? Really? What's its shape? Could it, like the Möbius strip, seem infinite but actually be finite? In topology, there's an even more complex structure called a Klein bottle. It can't be fully built in 3-dimensional space. It only works completely in 4 dimensions. The Klein bottle has no inside or outside and no boundary, yet can extend endlessly. Interestingly, some cosmological models actually use similar structures to explain a universe that is finite but without boundaries. If our universe were shaped like a Klein bottle, it would mean that the universe isn't necessarily just 3-dimensional. It might have higher dimensions. We just can't directly perceive them. In fact, modern physics, particularly string theory, suggests that the universe may have at least 10 dimensions. M-theory, a more advanced framework, proposes 11 or even more. All of these theories point to a similar conclusion. What we see as our world is just a lower dimensional projection of a higher dimensional reality. Here's the challenge. Our sensory system is built for 3D. Our eyes, our hands, our nervous system, even the way our brains think, all evolved to function within 3 dimensions. Trying to understand higher dimensions is like a 2D being trying to grasp a sphere. It would only see the sphere as a series of flat cross-sections as it passes through its world. It can never see the full shape. This limitation in thinking is fundamental. Sure, humans can use math and abstract logic to describe higher dimensions, but that doesn't mean we can ever truly understand them, because we can't experience 4D space. Just like a fish can't imagine air. Just like a shadow can never touch the light source. Maybe the 4th dimension is real. Maybe the universe is structured in 4 or even more dimensions. But as 3-dimensional beings, we may never be able to cross that invisible boundary in our understanding. So when we gaze up at the night sky, wondering about the edge of the universe, we have to accept a possibility. We may never be able to see the 4th dimension. We might never fully understand it. And yet, it's precisely that mystery, that unreachable unknown, that makes scientific exploration so captivating. Just as we, in our 3D world, marvel at the limits of 2D life, Perhaps higher dimensional beings are watching us, smiling at our struggle to grasp the fourth dimension.